Hello guys, welcome to my channel. In this video, we shall be talking about dimensions of physical quantities in physics. Firstly, what is dimension or what are dimensions? Dimensions are measurable properties used to describe the physical state of a body or a system. In physics, we have three basic fundamental quantities. They are mass, length, and time, t. Before we continue, let's note that any measurement along a straight line is regarded as L. Any measurement along a straight line, either vertical or horizontal, they are all regarded as L. Our mass remains m and our time remains t. Okay, now quickly let's check some examples. What is the dimension for area? Area. The formula for area is length times breadth. Okay, now from the three basic fundamental quantities, length is regarded as L, and breadth is a measurement along a straight line, so it is also L. Therefore, L times L, we have L squared. So L squared becomes a dimension for area. Secondly, let's check the dimension for volume. Volume is equal to length times breadth times height. Okay, therefore we can say that length is given as L. Breadth is also a measurement along a straight line, so it is L. Height is also a measurement along a straight line, a vertical height. We have L. So L times L times L, we have L cubed. L raised to the power of 3 becomes a dimension for volume. Next, let's get the dimension for speed. Speed is equal to distance divided by time. Now, distance is a measurement along a straight line. It's a measurement along a straight line. So my distance can be regarded as, our distance can be given as L, and our time is always t. Okay, from the laws of indices, this can also be written as L times 1 over t. L times 1 over t. So therefore, now from the laws of indices, we are told that if we have a to the power minus 1, can also be written as 1 over a. So let's check that out. So here we have L times t raised to the power of -1. So when you multiply that, you will have LT minus 1 as the dimension for speed. Okay, LT minus 1 as the dimension for speed. Next, let's look at the dimension for velocity. Velocity. The formula for velocity is displacement over time. Now, displacement is a distance traveled in a specified direction. So from the three basic fundamental quantities, displacement can be replaced by L, and our time is always t. From indices again, you can bring the denominator up, it will become LT raised to the power of -1. So LT raised to the power of -1 becomes a dimension for velocity. Quickly, let's check the dimension for acceleration. acceleration is equal to change in velocity divided by time. So recall that the dimension for velocity is lt raised to the power of minus 1 and time is t. Again, bringing the denominator up, we're going to have lt to the power minus 1 times t to the power of minus 1. So from your indices, pick one of the base and add the power. So we have lt raised to the power of minus 1 minus 1. This will be equal to lt raised to the power of minus 2 as the dimension for acceleration. Okay, quickly let us check the dimension for force. Force is given as mass times acceleration. Okay, so our mass remains m and acceleration remains lt to the power of minus 2. So when we multiply this, we have mlt to the power of minus 2 as the dimension for force. Okay, next let's check the dimension for work done. Dimension for work is force times displacement. Force times displacement, and recall we already have the dimension for force to be mlt to the power of minus 2, and our displacement is a measurement on a straight line, so it is L. So when we multiply that, we have L times L, we have L squared, then t to the power of minus 2. So ml raised to the power of 2, t raised to the power of minus 2 becomes the dimension for work. Next, let's check the dimension for power. Power is equal to work over time. The rate at which work is done is the power. So recall we have the dimension for work already to be ml raised to the power of 2, t raised to the power of minus 2 divided by time is always t. Okay, now bringing the denominator up, we're going to have ml to the power of 2, t to the power of minus 2 times t to the power of minus 1, bringing the denominator up. From your indices again, we have pick one of the base and add the powers. So the dimension for power will be ml to the power of 2, t to the power of negative 2 minus 1. Finally, we have ml to the power of 2, t to the power of negative 3. This becomes the dimension for power. Next, let's check the dimension for pressure. Pressure, recall it is force per unit area. Force per unit area. The dimension for force is given to be mlt to the power of minus 2. And recall area is L to the power of 2. So we can say L will take away one L. So we'll be left with mt to the power of minus 2 over L. Bringing the denominator up again, we're going to have mt to the power of minus 2 times L to the power of minus 1. So multiplying, finally we have ml to the power of minus 1 t to the power of minus 2 becomes the dimension for pressure. Next, let's check the dimension for density. Density is equal to mass per unit volume mass per unit volume. Recall our mass remains m and our volume is L to the power of 3. L to the power of 3. So bringing the denominator up again, we have m times L raised to the power of negative 3. So when you multiply, you have ml raised to the power of minus 3 as the dimension for density. Quickly, let's check the dimension for momentum. Momentum is equal to the product of the mass and velocity. The product of mass and velocity give us momentum. Recall our mass remains our m and our velocity is lt to the power of minus 1. So when we multiply, we're going to have mlt to the power of minus 1. Recall, note that the power of each of these, m is 1, l is also 1, okay? So they're not important, but take note of that, okay? Now, next, let's check the dimension for impulse, okay? Now, what's the formula for impulse? Impulse is the product of force and time. The product of force and time. Now, what's the dimension for force? We have mlt to the power of minus 2 and our time remains t. So when we multiply this, we're going to have mlt to the power of minus 2 plus 1. Remember, the power of t here is 1. So when you pick one of the base and add the powers, we're going to have mlt to the power of minus 1. This becomes the dimension of impulse. In our next video, we're going to be looking at more quantities and their dimension. Please don't forget to subscribe to my channel and share this video for your friends who are maybe in need of these dimensions. Thanks for watching and have a great day.